Convidamos o senhor YONI ZIV da ECORI Energia Solar para a sua apresentação no painel Mercado de Inversores no Brasil.
Hello, my name is YONI ZIV. I'm the Vice President of Business Development in ECORI Energia Solar. We are one of the strongest distributors for PV equipment in Brazil. I have more than 15 years of experience in the solar industry. I was 10 years in a company named SolarEdge, where I was the Vice President of Technical Sales. Today I'm going to present to you the future of solar energy, which is the MLPE. I will explain about it in a short minute. Okay, so this is the picture that everybody have in mind when they're talking about a solar system. The installers know that there are much more behind that, but the end user, the system owner, only thinks about panels, and that's what he have in mind. He doesn't know about technologies, he doesn't know about inverters, he doesn't know many things, just that what he thinks that will be on his roof, and there is only one question in his head. I guess you all know what's this question. The only question people think about is how much does it cost? Quanto custa? They don't care about technologies, not because it's not important, just because they don't know about it. And in this case, this is a very big problem, because this is technology that need to last. It's an investment that is for 20, 25 years. It is not just a component that you buy and after 1 year you replace it. Would you imagine thinking about only how much it costs when you, for example, want to buy a car or other technology device that lasts for many years? For example, you have this car. It's a car, it's expensive, but it's completely different from this car. Both of them are cars. Both of them will take you from one point to another point. And of course, the tuk-tuk is way cheaper than the other car. But do they have the same qualities? Would they last the same? And actually, which car would you prefer? The main component in solar system is the PV panels. There are many types of panels, different brands, different technologies, silicon, thin film, 60 cells, 72 cells, many different types. And each panel, even within the same type, from the same branch, has its own fingerprint, a special, very unique characteristic, which is given in the form of IV curve. You can find similar IV curve to the panels in every data sheet of every panel. And this differentiates them not just because it gives the specific power, it gives the characteristic of the current and the voltage the panels are working in the different working points. And this IV curve also changed dramatically with irradiance and with temperature. The cooler it gets, the voltage increase, and the more irradiance, the more current you have, because more photons hit the panel and then you have more electrons generated. The problem is when we have many panels with different IV curves, even if the difference is very small, you have loss from what is called mismatch. Because a traditional inverter have an input, every MPPT, maximum power point tracker, has an input, and it can run only one current in series. This is laws of physics. And when you try to have only one current that tries to satisfy many panels, and each one has a slightly different IV curve with slightly different best operation point of current, then you get losses. Not because the inverter is not good. The inverter can be amazing with 100% efficiency. But if not all the panels have exactly the same IV curve, you will get power losses. And this is the biggest problem of traditional system. There are many causes for the mismatch and differences in the irradiance and the temperature, coming from little cracks from the transportation, and you can have a little different angles of orientations, you can have shading, You can have different temperature because of wind, panels in the front and panels in the back. And you know that world is not optimal always, and you have tolerance from the manufacturing, even from the same factory. The silicon, you know, is the way it's generated. It always have some differences, and the companies try to give us very identical panels and sort them, but it's never 100% sorted, and you always have differences. And the bigger the differences, the bigger the losses you have from these differences. Life with a traditional string inverter is like being in a traffic jam. You can have a very good panel, you can have a very good car and a very good driver. But if the drivers in front of you or the back of you or side of you drive slow, they're now unfocused, they're talking on the phone or on the WhatsApp, you will be stuck, not because of your fault, because the road is serving many, many different cars, many different panels. Some of them are slow and some of them are fast, and they all affect one of the other. And here came the idea that will change the industry forever, the idea of MLPE, module level power electronics. This idea started with companies of microinverters somewhere in the 80s, and later came a company named SolarEdge that did this different kind of MLPE. I will talk about both options in the next slides. When you have MLPE, you have module level power electronics. This is like giving a separate lane for each and every car. So you can drive as fast as you can, as fast as your car allows, or the driver, or the regulation, without the effect of other cars, slower cars, faster cars. You are alone. You have your own inverter. You have your own electronic per panel. The first and best technology that started this MLPE is the microinverters. We at ECORI will represent a company named AP Systems, which give a very good price value for money for these microinverters. And these microinverters are connected to the panels and give you module level electronic, which gives module level MPPT, module level monitoring, module level safety. You have full flexibility because there is no one inverter to connect to all of the panels together. Every panel has its own manager, his own inverter that gives him the best efficiency, conversion and monitoring and everything you need. A very nice thing about microinverters that everything is on the roof. You don't need to install inverter inside the house. This is something that people, remember I told you that when they think about solar system, they think only about the panels on the roof. Nobody thinks about, oh, now I need to find a wall and put an AC breaker and DC breaker and put an inverter on this wall and connect the internet. Here, everything is very simple. Everything is on the roof. You don't need to sacrifice any wall in your house. And that's why this technology is very, very strong for the residential market. The second option is SolarEdge, is a company I came from before ECORI. They have a different concept of MLPE. They say, okay, let's try to give all the benefits of microinverters, but with technology more similar in practice and in price of string inverter. What they actually did, they broke the inverter in a good way. They put the two functions of the inverter, which are MPPT and DC to AC conversion, and set every functionality where it belongs to. The DC-DC MPPT at the panels with this optimizers, and at the grid connection, a very, very good, efficient and cheap inverter that is only taking the optimized power and convert it to the AC grid. Many people ask, okay, so which technology is the best and how can you test? And they do all kind of comparisons, which none of them is really good. It's almost impossible to have academic level comparison. And the only good academic comparison I know about was done by NREL, which is the National Renewable Energy Laboratory of the United States. And they compared for a long while microinverters, optimizers, and string inverters. And in many cases, you see that the optimizers are a little better than the microinverters. In some cases, the microinverters are better than optimizers. But if you look carefully at the results, you see that actually production-wise, optimizers and microinverters gives identical results, maybe a fraction of % here and there. And you can see that the big change is with the string inverter. String inverter, unless the conditions are 100% optimal, in any condition which is not 100% optimal, a string inverter perform much worse than MLPE, either a microinverter or optimizer. And this is important because we look at this solar system as an investment. And when you talk about investments, there are three things that you care about. You want to increase the revenue, reduce the expenses, and reduce the risk. So how can we increase the revenue? I think that's pretty obvious. You have the module level optimization, so you have more energy. You can put more panels on the roof because you have flexibility. So you actually get much better production, and you can sell more panels as a reseller. So revenue-wise, there is no question that MLPE is the best. The more interesting question is, how do I reduce the expenses? Because it's maybe a little bit more expensive, but this higher expenses is only at the capital cost and the initial cost. For the project lifetime, when you take into account the warranty of the system, the value of much simpler operation and maintenance because of the monitoring, you get much lower OPEX, operational costs. And when you have better OPEX, then the complete project ROI, return on investment, get much better, and you also have much better warranty and guarantee that your system will function better for the lifetime because you have the monitoring and visibility to what's going on in your system and not just hope that everything will work well. Coming to the last point, which is the risk reduction. With MLPE, you have module level shutdown in case of fire, in case of problem, in case of AC disconnect. The first thing that firefighters do when they come to the roof is disconnect the AC because they don't want to get electric short. And when you disconnect the AC, in traditional system, you get higher DC voltage because the panels go to the V open circuit. Here, because every panel is separated, you maximum get the V open circuit of one panel. And in microinverters, you get like 0 power at the output. With the optimizers, you get 1 volt at the output. So you're in a very safe point compared to traditional string inverter. Would you imagine buying a car without a safety belt? This is a commercial advertisement of a Volvo company from 60 years ago. At that time, safety, seatbelt was a feature. It was something it was nice to have. Today, you would not imagine buying a car with no safety, seatbelt, airbag, AWS, etc., etc. Today, in Brazil, it's not mandatory, but in many countries, these regulations come, and I'm sure a few years from now, we would not imagine that we could buy a system with no safety inherent as we do today. MLPE give you this safety feature today. So with a solar system based on MLPE, you know that you made the right choice for you and for your customers, getting the best monitoring, the best operation and maintenance, simple design, flexibility, more energy, and most important, you have the safest system possible. I hope this was interesting and you learned something from this short presentation. Thank you very much. I was YONI, and on the name of ECORI, I would like to thank you. Thank you very much.
Agradecemos o senhor YONI ZIV da ECORI Energia Solar por sua apresentação.